Hi folks, so this is the first of a series of video lessons we're producing, really going through the same kind of material we'll be covering in class each week. It won't be an exact approximation. Some things work great in class but don't work in a video, and vice versa, but it'll be pretty similar. What it means is that if you, for any reason, can't attend class, if you could attend but you just didn't quite pick something up, you've got a chance to have another go and just go through the kind of stuff we were covering in that lesson. So today's lesson is called Types of Number. It might sound like a strange idea, types of number. What we're talking here is things like square numbers, cube numbers, prime numbers, factors of numbers, that kind of thing. If you don't understand any of that, don't worry, we'll be going through everything here. But there's a whole, it'll seem quite bitty, this. There's all sorts of little bits here and there that could just take a bit of getting used to. Quite a lot to learn. It's quite a lot to cover in one lesson. But I would say most of the content is fairly light. There's nothing that's particularly heavy here. It's just a lot of individual bits of stuff. Do bear in mind, as with all these videos, this is kind of a homebrew thing, so it won't be anywhere near as slick as you would find on a lot of stuff on professional quality stuff. But hopefully getting stuff that's being provided by the same people who are teaching you should be of some use. I hope you get something out of it. Right, anyway, let's make a start. So first of all, a little definition for you. This is the word integer. Now, this is one of those words in maths that you need to recognise. You never need to use it, but you need to know what it means. And as it says here, an integer just means a whole number. 0, 1, 2, 3, for example, or negative numbers, -1, -5, whatever. Not fractions, not decimals. And everything that we're looking at today is to do with integers. So it's one of those words I want you to just to know what it is. An integer just means a whole number. You certainly need that in exams. They will refer to integers. Quite often I have students say, why didn't they just say whole number? Well, mathematicians are like that, I guess. They like to sometimes use fancy words that have a different. Most people in the real world would use a different word for, but just one word I need you to be able to recognise. Right, okay, so that's that definition over. Right, let's have a look at the first kind of number then. So what we're talking about first of all is square numbers. Now, to square something simply means to multiply it by itself. So for example, if I was to take the number 7, try that again, oops, lazy. Take this number 7, and to square it, to multiply it by itself, then I would get 49. Or if I were to take the number 15, I was to square it, multiply it by itself, I would get 225. Now we can write squaring just by writing the number times itself, but what you can also do is write it as it says here with this little 2 just above. So 3 squared means 3 times 3. That little 2 at the top here simply means multiply 3 by 3. By the way, a very, very common mistake that you often hear people or see people do is to think that means to multiply it by 2. Notice that's different. 3 times 2 would be 6. 3 times 3 is 9. They're not the same thing. So here we've got 7 squared, 7 times 7. And again, in fact, I better put some answers here, hadn't I? So this would be 9, and this would be 49. Now, a square number is what you get when you square an integer, when you square a whole number. So let's have a look at some of those. So if we were to take the number 1 and we were to multiply it by itself, we'd have 1 times 1. That would give us the answer of 1. So 1 is an example of a square number, a number that is the result of squaring an integer, squaring a whole number. So 2 multiplied by itself, 2 times 2, is 4. So 4 is a square number. 2 isn't a square number. 2 is not the result of multiplying something by itself. 4 is because it's the result of doing 2 times 2. 3 multiplied by itself, 3 times 3 would be 9. 4 multiplied by itself, 4 times 4 would be 16. 5 multiplied by itself, 5 times 5 is 25. 6 times itself, 6 times 6 is 36. 7 multiplied by itself, 7 times 7 is 49. 8 multiplied by itself, 8 times 8 is 64. 9 times 9 is 81. And 10 multiplied by itself is 100. Now these then are all square numbers. The list doesn't stop there. You can square 11, 12, 13, 14. You can square any number you like, and you will get a square number when you do that. These ones I would recommend that you learn. These come up often enough that it's it's worth just knowing that, for example, 64 or 25 or 9 is a square number. Okay, so this is a typical exam question that you might see. So this could be straight from a GCSE exam paper. So from the list below, circle the square numbers. So we've got some numbers here and the question is, which of these are square numbers? Now, this is where it's really handy if you just know which ones are the square numbers. So if you remember from your list here, these numbers here, then you can answer this question almost straight away. If you don't know it, there's a couple of different possibilities. One is just to think about what would it be. So, for example, you might look at 14 and think, can I square something to make 14? Can I multiply something by itself to make 14? I can't think of any number that multiplies to make 14, no whole number anyway, so 14 isn't a square number. 16, however, I can recognise. I realise that 4 times 4 is 16, so 16 must be a square number. That's one answer there. What else will be the result? Will be the result of multiplying something by itself? Well, I can't think of two numbers. I can't think of a number that multiplies by itself to give 37, or 72, or 80, or 99. But I do recognise that 9 times 9 is 81. So 81. Should we try that one again? 81 is a square number. But again, it's just much easier if you know your square numbers. As we'll see in a few minutes, there is another way of finding out whether a number is a square number or not if you don't know them. But if you do just learn your early square numbers, it can't do you any harm. It's going to save you time in an exam. Okay, as well as squaring numbers, we have another operation called cubing numbers. So to cube a number, as it says here, is to multiply it by itself and then itself again. In other words, 3 of it being multiplied. So for example, if I was to take number 2 and I was to multiply it by itself and then itself a second time, that's 1, 2, 3 2's being multiplied, then the result of doing that is a cube number, in this case 8. Now, you can write cubing as just 3 of it being multiplied together, like you can see here, but a little time saver, which I think you can see is just definitely going to say a bit of writing, is to put a little tiny 3 above it like that. So 5 cubed means 5 times 5 times 5. And again, the answer for that would be 125. So 125 would be a cube number. 10 cubed, 10 times 10 times 10. Again, a bit of a delay there, is 1,000. 1,000 is a cube number. So it's certainly quicker to use this little 3 above here, and you will see that being used in exams. So it's definitely something I want you to recognise. Cubing is the little 3 above here. Again, it doesn't mean multiply by 3. So 5 times 3 is 15. 5 cubed, 5 times 5 times 5 is 125. 10 times 3 is 30. 10 cubed means 10 times 10 times 10 is 1,000. So that's cube numbers. So square numbers are the result of squaring something. Cube numbers are the result of cubing something. Right, let's have a look at a few examples of that. So we've got number 1. If we multiply 1 by itself and then itself again. So notice you're multiplying it by itself twice. There's 2. You multiply it once, twice gives you 3 in total of that number being multiplied together. So 1 times 1 times 1 means that the number 1 is a cube number. 2 cubed is 2 times 2 times 2, or 2 times 2 is 4, times 2 is 8, so 8 is a cube number. 3 times 3 times 3, 3 3's are 9, times 3 again is 27, so 27 is a cube number. 4 times 4 times 4 is 64, so 64 is a cube number. 5 times 5 times 5 is 125. So 125 is a cube number. Generally that's the ones you have to learn. You could do 6 cubed, 7 cubed, 8 cubed, and so on. You don't really see those in exams. Occasionally I've seen 10 times 10 times 10, giving you 1,000 as a cube number. Right, so a couple of questions here. So first one says, write down the cube number between 60 and 70. Now again, there's a couple of possibilities as to ways of doing this. The best thing to do here is just know it. If you know, going back to our list, that 64 is a cube number, then write down the cube number between 60 and 70 is trivial. It's just 64. Note those words here, write down. Not calculate or work out, but write down. Write down questions in exams typically mean questions where you should just know the answer. There shouldn't be any calculation to do there. If you know 64, if you've practiced, if you've learned that it's a cube number, it's really, really straightforward. As I say, I'll show you later on a little way in which you can find out if a number is a cube number, but generally I would say the best thing to do is to just know them. Now, we've talked about squaring a number. To find the square root of a number is to do the opposite thing, and maths is huge on opposites. There's lots and lots of examples where you have an operation, something you do, and then you have the opposite operation, something that you would do to undo that. So, best learn with an example. So, what's the square root of 81 means what number, if I square it, gives 81. What multiplied by itself gives 81. Now, this is where recognizing and knowing your square numbers is very handy. Again, if you went back to the slide we looked at earlier, we'd see that 9 times 9 is 81. So the cube root, sorry, start again, the square root of 81, get ahead of myself there, the square of 81 is just 9. By the way, something I've noticed people doing in the past is they've said that the square of 81 is 9 squared. That's not true. 9 squared is 81, so the square root of 81 is just 9. Again, the answer to that question, what number, if I square it, gives 81, is just 9. Now, you can write it as, in words, what is the square root? But you can also use this symbol here. This symbol here is means square root. So to write the square root, we first of all write that symbol, and then we put the number we want to square root on the inside of that. So again, this here, square of 81, is the same as we got here. That means what number, if we square it, gives 81. And again, the answer would be 9. Now, another important point. Square numbers are always nice numbers. They're always integers, whole numbers. Some square roots are nice, some are not. Sometimes when you square root something, as we'll see in a second, you get something that is very, very messy and unpleasant. But, and this is the good news, you can always use a calculator to find them. So if you haven't at this point in the video got your calculator out, I want you to go and get your calculator, there it is, and I want you to find it and I want you to use it. Don't use a calculator on your phone because it's different, it works in different ways. Don't use a calculator on the internet because you'll be flicking between two different windows in a browser. Just go and find your calculator. If you haven't got one, you can get them in UCM reception. This is a Casio. The ones you get in reception are a Logic, but it's basically the same thing. I think it's one button that works slightly differently. It's an identical model. I don't quite know what the difference is between them in terms of companies, but one is definitely a rip-off of the other. So yeah, go and find your calculator and get that on your desk before you do any more, because you need to be able to refer to the buttons I'm going to be talking about on that. Right, so how do you find a square root? You need to press the square root button, and I've got a little video here, I've got a picture here, I should say, showing the square root button. It's this little one inside here, inside the red circle. So to find a square root, you press that button first. In other words, what the mistake a lot of people make is that they, first of all, let's say you want to find the square root of 81, is they type the 81 and then they press this button. That won't work. You have to do it the other way around. You have to, first of all, press the square root button. That will then appear on your screen like that. Then you go and fill in the numbers. And if you hit the equals button, which is down here, I was pointing on the best code to use, there, then it will give you the answer, in this case 9. Right, let's have a look at some examples then. So again, I recommend that you do this, go along as I'm doing the questions here, do the same thing. Have a look, because I want you to see what it shows you on your calculator. And I'm going to do the same here where I need to. Some of these I know and some I definitely don't know. So I'm going to do the same thing. So square root of 25. Again, I'm going to press the square root button first of all. I'm going to press the 25. And then that will show me on the display 5. So let's just check why that is. That's the square root of 25 is 5. Why? Because 5 squared, 5 times 5 is 25. Let's do the same here. If we square root 81, so square root button first, then the 81, hit the equals, you get an answer of 9. Why is that? Because 9 squared, 9 times 9 is 81. And we'll do the same, square root of 100. And again, if you tap in your calculator, hit the equals button, it'll give you 10. Again, why? Because 10 squared, 10 times 10 is 100. Now let's do the same with the 2 here. So first of all, I'm going to type the square root button. Then I'm going to hit 2. I'll do this now. And here's where the weirdness can happen. If you press that, the first thing you will see on your screen is that. It doesn't actually give you the answer. It doesn't show you what the number is. Now, why is that? If you get something like that happening, then it's because it's not actually a whole number. What you want to do now is press the S to D button, and that on my screen, I'm just going to change pen color so you can see this better. That should do the trick for a second. Okay, that is the SD button is there. If you press that button there, you'll then get a different display. What it will now look like, I'm just going to switch back a second. Here we go. Is, okay, I get that to be 1.414213562. And that number actually keeps going. That's the limit of the calculator. That's as far as it displays. In other words, it's really not a nice number. It's quite surprising that. You might think that there is a nice number, that if you multiply it by itself, you get 2. There isn't. It's actually 1.414213562. Keeps on going and going and going. That's not a nice round simple number. So many square roots are not whole numbers. They're not integers. They are very, very messy decimals. If I ever wanted in a class just to quickly display an awkward number or a horrible number, one way of doing it would be to square root most numbers. You'll get something a bit horrible like that. Right. In a test, it depends what the question says, but normally what I would suggest is that you want to give the answer in that form there. There may well be a rounding as well. It may say round it to 1 decimal place, 2 decimal place, something like that. Stuff you should have seen on UCM Maths last week or the week before. Right, let's try again. Let's try the square root of 32. So again, type up my calculator, square root 32. Again, another weird thing happens. This time it says this. Okay, I'll just pause for a second, let you catch up there. So square root 32 equals, and you get this funny looking thing here. Now, don't worry why it does that. What you have to remember is that this thing here is a tool that's not just used for foundation tier GCSE, which is what you're doing. It's also used for higher tier and for A level and for degree level math studies. And sometimes it has features that you just don't need to know. It's not necessary. It's not that you're not capable of understanding it. You just don't need to know why it's doing that at the moment. Okay, so again, the SD button we saw on a previous slide, I'll click that and I get an answer of 5.6568542449. And again, it would keep going if the calculator had more capacity for longer displays. But that's, again, you'll be asked to, almost certainly asked to round it to 1, 2, 3 decimal places, something like that. Finally, square root of 183. I'm going to plug in my calculator. So it's square root of 183. This time it just shows us square root 183. It doesn't do whatever weirdness was going on here. It doesn't do that. It just shows you the same thing. Again, I'm not going to explain why. I could, but it's not necessary for what we're doing at the moment. I'm going to hit my SD button and I get an answer of 13.5277492.6. Keep going. Right, so square roots are sometimes nice numbers. They're sometimes integers or simple decimals. Quite often they're not. They're messy, horrible decimals like we've got here. Don't worry, just check if you get one of those on your calculator display. Check the question and see, does it tell you how to round it? Now, we looked before at a question where it was asking us to circle the square numbers. But let's say we had a number like this, a question like this, 4,225. Is that a square number? Okay, so I'm looking for a number which, if I multiply it by itself, gives me 4,225. Now, if you can imagine, that we could be doing a lot of trial and error to find that. That could be a a really big job trying to find that if we did it by just plugging numbers in and seeing what worked. Again, it may not take as long as you think. With a little bit of trial and error, you might find the number. But there is an easier, definitely a better way of identifying if that's a square number. What we can do is we can find the square root. So on your calculator, I would like you to plug that in. Find the square root of 4,225 and see what that comes to. I'll do the same here as well. Okay. And on my calculator, I got an answer of 65. Now, why is that useful? What that tells me is that 65 squared, in other words, 65 times 65, is 4,225. So that tells me that 4225 must be a square number. Why? Because it's the result of multiplying a number by itself. So a really good check as to if a number is a square number is to find the square root of that number. If, when you find the square root, that's an integer, if it's a whole number, there's that word again, integer. If it's a whole number, then we know, yes, it is a square number. If it's not a whole number, then it's not a square number. Right, let's have a look at this question here. So which of these is a square number? So we've got 3 numbers here, and we're trying to identify which one is a square number. So all we're going to do is we're going to find the square root of each of these. I'll do that now. You can do the same, and then we'll have a look at those, and we'll compare answers in a second. Right, you might actually want to pause the video at this point and then come back. Okay, so I got the square root of 3135 to be 55.991, blah, blah, blah. Now, I could write more there, but frankly, that's enough. That tells me this is definitely not a square number. It's not the result of multiplying something by itself. The square root of 3136, on the other hand, is 56. And the square root of 3137 is 56.0089, blah, blah, blah. Right, what that tells me is that this number here must be the square number. It's the result of multiplying 56 by 56. I get 3136. So it's the result of squaring an integer, so therefore 3136 is a square number. Now, just as we have the square root of a number being the opposite of squaring, we also have the cube root of a number being the opposite of cubing. So let's look at this example here. What is the cube root of 8 means what number, if I cube it, gives 8. So let's just write that down. So something times itself again gives me 8. What number would that be? Have a think for a minute. You can pause the video if you like. Okay, now it might just pop into your head, maybe a bit of experimentation. Again, you can always use a calculator to check things if you like. But with a little bit of experimentation, we might see here that 2 times 2 is 4, times 2 again makes 8. So the answer to that question, what is the cube root of 8, is 2. By the way, it's not 2 cubed, as you often hear people say. 2 cubed is the number 8, which is not what we're looking for. We're looking for the number which, when you cube it, gives us 8. So if you look here again, 2 times 2 times 2 is 8. So the answer is just 2. Now, you often see it written like this, as cube root, but you also have a symbol for writing that down, which is good to know, which is the square root symbol with a little tiny 3 just above it here. And I'll show you in a second how to find that on the calculator. So that there is saying what is the cube root of 125. Again, just before we move on, let's have a think about that one. So again, you might want to pause the video. What number, when you multiply it by itself and itself again, gives you 125? Okay, again, it's a little bit harder to spot, maybe because there's a bit more experimentation to do, but with a bit of practice or a bit of experience, you might get the answer, which is 5. 5 times 5 is 25, times 5 again is 125. If you knew that 125 is a cube number, that's the page we looked at a little while ago, then that might also help you spot that the answer will be 5. But as I said, you can always plug these into a calculator. Don't worry too much about remembering these. Cube roots particularly can be a little bit awkward. As with square roots, some cube roots are nice and pleasant numbers and some are not. And again, as with square roots, you can use a calculator to find them if you're not sure of a number or not sure what a cube root would be. And I would generally recommend, if you're in any doubt at all, use a calculator. Right, so how do we find the cube root with a calculator? Right, it's actually the same button as square root, but we have to activate the kind of secondary button. So a bit like on a keyboard, we do the same thing, we use the shift key. We do the same with the calculator. So you press this green button up here just once and then let go. You should find in the top right hand corner up here, you get a little tiny S appears. Then you press the square root button. And again, you do that before you type the number. So if you wanted, for example, to say find the square root, the cube root of 125, for example, when we looked at a second ago, then you first of all press the cube root button like that. Again, so it's shift and the square root button. Then and only then do you type the number in. Then you hit the equals button, which is down here, and then it will give you the answer. Now, let's do the same with some of these. So let's see if we can practice finding cube roots. So again, I'm going to do the same thing. I'm going to press my cube root button. That's the little 3 up here, the cube root button. I'm going to type 27. I'm going to hit equals, and I get an answer of 3. So that's an example with a nice number. Here's the one we saw a second ago. So we're going to type the cube root thing first, then type the 125. Then hit equals, and we get again a nice round number 5. Right, try the same with 1,000. Again, if you want to pause at any point, then feel free to do so, and then just play me when you're ready to go. So here I'm going to type the cube root button first, as we saw in the previous slide, then type 1,000, then hit equals, giving me again a nice round number of 10. Right, now the next one, this isn't going to be so pleasant. So I'm going to, again, cube root button first, type my 10, so that should be a 3 there, beg pardon. Try that again. I'm just going to redo that because it'll be a bit hard for you to see otherwise. Right, so it's the cube root button first, then type the 10. I'm going to do the same on here. Now, this time it doesn't actually give me the that funny thing with the square root symbol as we saw in the square roots. It just gives you a decimal. It will normally do that, and there might be the odd exception, but normally it'll just go straight to the number. Again, don't worry why. That's A-level maths at least. Let's just write the number down. So I get 2.15443469. Again, that will carry on literally forever, but that will be as much as we would need. And then you just need to see what the question says in terms of rounding that number. Again, typically 1, 2 decimal places, something like that. Right, so we're going to do the same for cube root of 223. So again, same thing. So I'm going to write my cube root symbol in first, type the number 223, and I get that to be 6.064126995. That should be a 9. There we go. Carries on forever. Finally, I've got the cube root of 1,000,000. 1, 2, 3, 4, 5, 6. Don't forget my little 3 over here. Plug that in my calculator, and actually this is going to be a nice round number. 1, 2, 3, 4, 5, 6. Hit my equals, and that's going to be an answer of 100. Just explore why that is for a second. If we go, just take that one here. Why is that 100? Because 100 times 100 times 100 is going to be 1, 2, 3, 4, 5, 6, 1,000,000. Right, so that's how you find a square root, sorry, a cube root, pardon. You first of all hit the cube root button, as we saw in the previous slide, then you type the number in, then you write that down. And again, as always, whenever in a test you get a messy number appearing on the calculator display, read the question, the exam question, and see, does it tell me how to round it? If it doesn't, just choose something that you think would be suitable. Typically 1 or 2 decimal places would normally be fine. It would normally, though, tell you, if you've got a messy answer coming up, it's not going to tell you how to round that. So to give you a bit of advice as to what to do with the number. Okay, so in this part of the lesson, we're going to look at a new thing, and this is what we call the factors of a number. Now, again, we're only talking about integers. Remember, that's whole numbers. So the factors of a number are the numbers that an integer can be divided by. And I probably should add here to leave you with another integer. Sometimes you can overcomplicate definitions, so I haven't written that down here, but that's what we mean. A number that you can divide a whole number by to leave you with another whole number. Again, often learned as the numbers that go into a number. Mathematicians tend not to like that definition. It's a little bit loose, a little bit unclear. Students tend to love it, so you go with whichever version works for you. Right, okay, let's take an example. So if I wanted to find the factors of 20, then I'm looking for what numbers I can divide 20 by. Now, again, I recommend that maybe you want to pause the video at this point here and see. I'm going to start you off. I'm going to tell you that 20 can be divided by 2, because 20 divided by 2 gives you 10, which is a whole number. So there's your first example of a factor. Right, pause the video, have a think, what other numbers you can think that you can divide 20 by, and then we'll see if we agree. Okay, so I can divide 20 by 2. What else can I divide it by? Well, I could divide it by 4. That would give me 5. I could divide it by 5. That would give me 4. I could divide it by 10. Any more? There's actually another one. I could divide it by 1. 20 divided by 1 gives you 20. And finally, I could divide it by 20 itself. 20 divided by 20 gives me 1. And that should give me all the factors of 20. Now, if you got all of those, great, well done. If you missed any, then maybe what we need to think about is a technique. The problem with doing what we've just done there is we've just I just thought like the first number that came into my head, and then the next one, the next one, the next one. And it was very easy to miss something there. It's very easy not to notice a factor. Something just slips by you. So what we could do with is a method. We could do with a way of finding factors that is a bit more reliable. Let's have a look at an example. So we're going to look at what we call the horseshoe method. Now, let me stress, you don't have to do this. It's not absolutely necessary at all. It's a recommendation. I think this just makes things easier if you do. So here's how I would find, in this case, the factors of 24. Right, I wouldn't just randomly think of the first number that pops into my head. I think that's dangerous. I think we'd likely to miss something if we do that. What I'm going to do is I'm going to start off with a number that is the factor of all numbers, and that's number 1. So 1 is a factor of 24. 24 can be divided by 1. And notice that that pairs off with another number. 1 times 24 gives me 24. All numbers have themselves as their own factor. All numbers can be divided by themselves. So I'm going to start with 1 and 24. Now again, I'm not going to just randomly think of the next number. I'm going to, after 1 comes 2. So I'm going to put 2. And 2 pairs off very nicely with, 24 divided by 2 is 12, or 2 times 12 is 24. So 12 must be a factor. After 2 comes 3. Yep, 24 can be divided by 3. That's great, so I can do that. What would you multiply 3 by to make 24? Well, that would be 8. After 3 comes 4. 4 is a factor. I can divide 24 by 4, and that gives me 6. Now, then I'd have 5. 5 times, the trouble is that actually 5 doesn't multiply by anything to make a whole number. 5 5 times nothing makes 24, is what I'm trying to say. So 5 isn't a factor of 24. You can't divide 24 by 5. So the next number will be 6. But if we look at it, 6 times 4, well, that's just the same as 4 times 6. In other words, at this point, I can stop. I've got to the point where I have found all the factors. Any more I find here would just be a copy of one of these things up here, which we definitely don't need. Oops, there we go. Right, so now what I'm going to do is I'm going to put a little thing around here like this. And that's why we call it the horseshoe method. It just makes a horseshoe shape, I guess. You don't have to do this at all. I just think this makes it a little bit easier. So I'd like to have a little practice at this one here. I've just had my turn. I'm going to ask you now to find all the factors of, 30. Okay, so pause the video and have a go at that. See if you can find all the factors of 30. Okay, so let's have a look. Well, first of all, I'm going to go for 1 times 30. But by the way, again, these two numbers here, 1 and itself, are probably the most common factors to miss. People frequently don't notice that these two numbers. If I ask somebody to tell me a number you can divide 30 by, 1 and 30 are some of the least obvious of those, although they're the easiest to find. So 1 times 30. After 1 comes 2 times, well, that would be 15. After 2 comes 3. Yep, we can divide 30 by 3. 3 times 10. After 3 comes 4. Well, nope. In fact, a good check is if you want to see if something, if it's a factor, just divide it. And again, you can always use your calculator. So 30 divided by 4. If you plug that into your calculator, you get an answer of 7.5. Now, so 30 can be divided by 4, but it doesn't leave an integer, a whole number answer. So definitely 4 is not a factor. After 4 comes 5. Yes, 30 divided by 5 gives you 6. And the next number on will be 6. Well, that would just be a copy. 6 times 5 is the same as 5 times 6, so we don't need to do that. So again, we found all the factors. And there we go. So the factors of 30 are 1, 2, 3, 5, 6, 10, 15, and 30. Now, I would strongly recommend that you have a practice at a few more of those. If you go on to Hegarty, you'll find exercises on factors. Corbyn Maths is another good place if you want to look for some exercises on finding factors. But that method, the horseshoe method, I strongly recommend. I would recommend. You might have a different way. A teacher at school might have shown you something a little bit different. Great if they have. No problems. There are quite a few different ways you can do this. The one thing I'd urge you not to do is just think about something and put the first numbers that pop into your head. That's where things are more likely to go wrong. It's just going to miss something. Okay, as well as factors, we have multiples. Now, multiples are the result of multiplying a number by an integer. That's a sort of more technical maths definition. Also, we can students quite like this as the numbers that are the answers to its times tables, which I think is, again, a perfectly fine alternative definition. So let's take an example. If I wanted to know the multiples of, let's say, 9. Well, what would they be? They would be 9, 18, 27, 36. These are the answers to the 9 times table. 1 times 9 is 9. 2 times 9 is 18. 3 times 9 is 27. 4 times 9 is 36. So all these and many more are multiples of 9. Right, let's do a more orderly example. So I'm just going to, again, list the first 5 multiples of 8. So I'm going to start off with, in fact, you could even write this down as a multiplication sum. So 8 times 1 would be 8. 8 is a multiple of 8. 8 times 2 is 16. 16 is a multiple of 8. 8 times 3 is 24. So 24 is a multiple of 8. 8 times 4 is 32, so 32 is a multiple of 8, and finally 8 times 5 is 40, so 40 is a multiple of 8. These are all multiples of 8, they're all in the 8 times table. Right, okay, so if I'm going to ask you now to list the first, excuse my appalling handwriting, first 5 multiples of, let's say, 12. Okay. So again, just pause the video, just write these down. If you want to write the bit on the left, great. If you don't, if you want to write the answer down over here, I don't mind that at all. So pause the video and have a go at that exercise. Okay, so I'm going to start off with 12 times 1 is 12. So 12 is a multiple of 12. 12 times 2 is 24. So 24 is a multiple of 12. 12 times 3 is 36. By the way, don't forget, you can always use a calculator. I happen to know these because I'm a maths teacher and I've been teaching this for a long time. You can use a calculator whenever you want. It's perfectly fine. There's no harm in that whatsoever. 12 times 4 is 48. And 12 times 5 is 60. So the first 5 multiples of 12 are 12, 24, 36, 48, and 60. Okay, folks, so if you go to the PowerPoint that this lesson is kind of based on, you'll find this little exercise here where it invites you to go through question by question each of these relationships. So I'm going to give you an example here. I'm not going to go through this whole thing. It gets really messy. I think what I'd rather do is if you weren't able to attend class, or you want a bit of practice, go back over, have another go at this exercise, or have a go for the first time, see how you get on, and if there's anything that you're not sure about, then talk to us about it and we'll go through those questions. It gets a bit fiddly and to present on the screen. I think it's one of the exercises where it's much better, it was better done in class. I'd rather do that there, and then if you can do this exercise, try it, and if you get stuck, give us a shout. Right, okay, so let me just show you what you're trying to achieve here. So you've got 4 possible definitions, or relationships, sorry. Is a factor of is one, is a multiple of is another, is neither a factor nor a multiple of is the third, and is both a factor and a multiple of is the fourth. So the idea here is you're going to write down in this column here which of those 4 relationships is correct. I'm going to do the first couple of questions, then I'll stop. And if you want to carry this on and do it yourself at home and then bring those answers in, great. The reason why we're doing this is because it is incredibly common to find people get mixed up between factor and multiple. I mean, really common. People do this all the time to get the two confused, and it totally it throws away marks really easily from fairly simple questions if you get the 2 definitions mixed up. It's absolutely understandable that people do get mixed up, but it's something we're trying to kind of warn people about, I guess. Right, so let's look at the first one here. So this line here is 3 something 9. So is 3 a factor of 9? Is it a multiple of 9? Is it neither, or is it both a factor and a multiple of? Well, 3 is a factor of 9. Why is that? Because you can divide 9 by 3 to give a whole number answer. It just happens to be 3 again in this case, but the important point here is that this here is a whole number, an integer. It's not a multiple. If you think about the 9 times table, that starts 9, 18, 27, 36, and so on. 3 is not in that. It's not the answer to the 9 times table, so 3 is definitely not a multiple of 9. Now the next question, 9 something 3. Well, 9 is a multiple of 3. Why? Because if we were to write down the 3 times table, 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9. 9 is an answer to the 3 times table. It's not a factor. I can't divide 3 by 9 to give me a whole number answer. 3 divided by 9 is, if you put it into a calculator, it'll either say a third or 0.3 recurring, 0.33333333. Definitely not, it doesn't give you a whole number answer, therefore it's not a factor. Right, so again, have a go at the rest of the exercise. I would suggest you won't do it on the PowerPoint because if you click through that, you actually can do each question. It'll kind of do a question and reveal the answer, do a question, reveal the answer, which is quite a nice way of doing it. But have a look at that and then give us a shout if you're having any problems. Okay, so another kind of number we've got are called prime numbers. Now, prime numbers are, as it says here, numbers that have just 2 factors. And those factors are always 1, because 1 is a factor of all whole numbers, of all integers, and the number itself. So let's take an example. I've said here 7 is prime because it can only be divided by 1 and 7. So if we just to show you that, just to prove that, if I were to try and use the horseshoe method to find the factors of 7, what would I get? Well, I get 1 times 7. Well, I can't divide it by 2. That would give me 3.5, which is not a whole number. Can't divide it by 3 to give me a whole number, or 4, or 5, or 6. No other numbers other than 1 and 7 are factors. So if I were to do the horseshoe method, that's what I would get there. The only whole numbers you can divide 7 by to leave you with another whole number answer are 1 and 7. So 7 is a prime number. Now, it's a really good idea to know some of your prime numbers. Prime numbers get very big. In fact, there's no such thing as the biggest prime number. If you can know the first few, that's extremely handy. It will serve you well in later exercises. So you don't have to, but it's a good idea to know some of your prime numbers. Right, so let's have a think what we're going to do here. So you might want to have a go at this yourself. There's in the PowerPoint, probably the best thing to do is print off the page with the questions or this equivalent page here, and then just have a go at circling the prime numbers. But I'm going to try and I'll go through these one by one, and we'll see if we identify some of the early primes. So I said circle the prime numbers, right? So let's have a look. Let's go through these one by one. Right, first of all, let's look at number 1. Now remember the definition. A prime number has got two factors, 1 and itself. Let's imagine we did the horseshoe method with 1. Well, what can I divide 1 by? Well, I can divide it by 1, which multiplies by 1 to give me 1. And that's it, there's nothing else. So let's have a look. We'll do the horseshoe around here. How many factors does 1 have? Well, 1 only has a single factor, 1. So 1 is not considered a prime number. So it's easily gotten wrong, this. People frequently identify 1 as a prime number. The smallest prime number is, in fact, 2. Now, why is 2 prime? Because, should we try that again? Because if you did the horseshoe method, 1 times 2, that's it, nothing else. 2 has got only 2 factors, 1 and 2. What about 3? Well, I can divide 3 by 1. I can divide 3 by 3. Nothing else I can divide it by, so 3 is a prime number. 4? Well, no, definitely not a prime number. I can divide 4 by 2 to leave me with a whole number, so 4 is not a prime number. In fact, nothing in this column here, let me try that one again. Nothing in this column here, it's not as easy as it looks, can possibly be prime. These are all even numbers. They all, in this case, end in a 4. These cannot be prime numbers because they can all be divided by 2. Likewise, apart from number 2, nothing in this column here. Again, I'm just going to try that one more time. This is really tricky. There we go. Can be prime because they end in a 2, and therefore they're even numbers. Can't divide them by 2. Likewise, nothing here or anything here or anything here. Now, that's not to say that all these numbers therefore are prime. Many of them definitely aren't prime, but it's good to know, it's good to kind of reduce the number of numbers we've got to worry about if we remember that all even numbers, apart from 2, cannot be prime because they can be divided by 2. Right, back to this one here then. Is 5 a prime number? Well, again, if I were to do the same thing, I could do 1 times 5. Doesn't divide by 2, doesn't divide by 3, doesn't divide by 4. So nope, I've covered everything. So 5 is a prime number because it can only be divided by 1 and 5. Likewise, 7 is prime. You can divide it by 1 and 7 and nothing else. 9. Now is 9 prime? People often say it is because because it's an odd number, but actually there's nothing. Sorry, there is something else I should say that you can divide 9 by. 9 can be divided by 3. So I would say 9 is very commonly misidentified as being a prime number. It's definitely not. There's nothing you can say. There is something you can divide 9 by, which is 3. So 9 is not a prime number. 11 is prime. You can divide 11 by 1 and by 11, but nothing else. 13 is prime. 15 isn't prime. You can divide 15 by a couple of numbers. You can divide it by 3 to give you 5, or by 5 to give you 3. So it's definitely not a prime number. In fact, again, you might spot all these numbers here. These numbers that end in a 5 can all be divided by 5. So apart from 5 itself, here we go. Apart from 5 itself, no other number that ends in a 5 can be a prime number. However, let's have a look. 17 is prime. 19 is prime. 21 not, because you can divide it by 3. 23 is prime. 27 is prime. No, it isn't. No, pardon, sorry. Ooh. It's not prime. You can divide 27. Oops, lazy. You can divide 27 by 3 to give you 9, or by 9 to give you 3, so definitely not prime. 29 is prime, so what I meant to say. 33, 37, and so on. Now, again, it could go down this list. If you were to learn even these ones up here, that would be good. There are ways of finding out, as I'll show you in a minute, whether a number is prime. But if you can just learn some of your early primes, it does make things much easier and quicker, mainly in an exam. Right. Now, product of prime factors. So this is a good example of something that I think as a technique isn't too bad, but people get put off because of the language, and this can be sounded really, really complicated. So let's just have a look what we mean here. Product in maths just means multiplied. So the product of two numbers, say the product of 5 and 6 would be 5 times 6, which is 30. So product is just a fancy maths word. As we said, mathematicians love these. Fancy maths word for multiply. Now, all integers, all whole numbers, are either prime or they can be written as 2 or more primes multiplied together. Let me show you what I mean by that. So let's think about the number 6. Is 6 prime? Definitely not, no. 6 can be divided by 2 and by 3, so it's definitely not a prime number. But we can write it as some prime numbers multiplied together. We just said before that I said that you can divide it by 2 and 3. And in fact, if you do 2 times 3, 6 is 2 times 3. Yes, that works. So 6 can be written as the product, that's again the multiply, of some prime factors, numbers that you can divide 6 by. 6 is the same as 2 times 3. What about 10? Can we think of some numbers that multiply together to make 10 some prime numbers? By the way, it might be an idea if I were to actually write down some of your early primes. This is usually a good idea when you're doing this kind of question, is to write down the early primes so you know what you're picking from. Can you make 10 by multiplying some of these numbers together? Okay, well, a little bit of trial and error, or you might spot that 10 is just 2 times 5. So 10 can be written as 2 times 5. That's the product of its prime factors. What about 15? Well, again, have a look down the list here. Can we think of some numbers that multiply to make 15? Okay, well, I think in this case we would have 3 times 5. 3 times 5 makes 15. So 15 expressed as the product of its prime factors is just 3 times 5. What about 4? Can you think of some numbers that multiply together to make 4? Okay, bit trickier here. You may well have imposed the kind of artificial limit on yourself. 4 is just 2 times 2. I never said here that you can't use the same number twice, just that you can write it as some prime numbers multiplied together. So sorry about that, but it's one of those things that people often sort of don't note or don't realise. So 4 is 2 times 2, or to put it another way, 2 squared. What about 8? Well, 8 is 2 times 2 times 2. So we can write 8 as 2 times 2 times 2, or 2 cubed. By the way, people often hear say 2 times 4. That's kind of partly right, but it's definitely not the complete answer. But the problem is that 4 is not a prime number, so we can't write 8 as the product of its prime factors using 4 because 4 isn't prime. What about 50? Okay, getting a bit more tricky now, harder to see. Again, maybe a little bit of trial and error. We could find out 2 times 5 times 5, which would be 2 times 5 squared. But it's starting to get hard now, isn't it? And as we go further down this list, look at 6,000. My goodness, I mean, that's going to take us a very long time to find that if we were to do that by trial and error. So what you need is a method. And what I'm going to show you now is a method. However, and this is particularly important if you've been at school in the last couple of years and you've done this with another exam board, let's say Welsh board, I want you to remember that you always have a calculator. So the method you've been shown in school, you don't need to use. You always have a calculator. You can always use the calculator to help you find this. So I'm going to show you now a calculator method of finding this. One of the reasons why I'm doing this here and not using Hegarty Maths is because he's going to show you the long-winded way of doing it, assuming that you might not have a calculator. I want to show you the quick way of doing it using a calculator. So let's have a look at that now. Right, okay, so again, make sure you've got your calculator. I'm using Casio here. Logic calculator would work absolutely fine. Most calculators have got this feature on it. If you've got a different calculator to Casio or Logic, let me have a little look at it, or David, or whoever's your class teacher, and we'll just make sure that it's okay. But most have got this feature on. Right, so here we go. So again, make sure you've got it. If you haven't got your calculator on you, pause the video, go and find it, go and buy one, whatever, then come back and do it. You cannot learn this by trying to watch me doing it on a screen because it's just not going to work. Here's how we do it. So get your calculator. Type the number in that you want to do it. So I'm going to give you an example. Let's go back for the, we had a 50 before that we weren't, I wasn't, maybe needed to go over. It's not obvious, that one. So we're going to type the number 50 into the calculator. Okay, right. Have you done that? Good. Right. Now press the equals button on the calculator. That sounds really strange, that, but press the equals. Okay. When you do that, what's it going to display? It's going to display 50. Now, that's kind of obvious, 50 is 50, but we need to press that equals button or the next thing doesn't work. And I say that because like, this is the thing I myself tend to forget to do, is to press that equals button. Now we're going to press the shift key. And again, let me just switch pen colors for a second. Okay, so that is going to be, where are we? Sorry about that. Up here, that's the shift button up there. So we're going to press that just the once. And then we're going to press this button here. Now, again, you probably can't see this on screen. It's really small, but I've tried to identify exactly where it is on your calculator. And you should see the word fact appears. It'll appear in orange letters just above that funny little symbol you've got on the button there. So you press the shift key, you let go. Then you press the fact button on the calculator. And then what you should find now is the calculator is displaying the answer, which we said before was 2 times 5 squared. So that's what we do each time. We type the number, we hit equals, shift key once, then the fact button, then then straight away it should just display that answer as the product of its prime factors. Right, let's go back now and have a look at this one here. So try the same here with this one here. So let's go for 100. In fact, I'd better move back to here. So let's just do 100 on there just to make sure we're okay with that. So same thing again. Type the 100. Equals shift fact, and it should now display the answer, which will be 2 squared times 5 squared. Again, really not obvious unless you've used a calculator for that. There are other methods of doing it for non-calculator. You don't need to worry about that. I've checked mark schemes and stuff for Edexcel IGCSE. If you put this in, you will get the marks. You don't need to show any more method than we've just done here. So we've got 6 numbers here that we're going to, in each case, express as the product of its prime factors, again, using your calculator. So what I suggest you do is pause the video, have a go at each of these, put your answers down on a piece of paper, or again, you could annotate the PowerPoint if you like, if you print that off, and then we'll go through them together. So I'll give you a second just to pause the video, and then we'll take them there. Okay, and we're back. Right, so let's have a look. First question here, 124. So again, following the same procedure I've done before, I'm just going to do it on my calculator. So 124 equals shift fact, and I get that one to be 2 squared times 31. 125, again, exactly the same thing. So we're going to do 125 equals shift fact, and that is just 5 cubed. Remember, actually, before we looked at 125, so that was a cube number. 140, again, do the same. So equals shift fact, and I get that to be 2 squared times 5 times 7. 150, again, 150 equals shift fact is 2 times 3 times 5 squared. And 500 equals shift fact, and we get 2 squared times 5 cubed. Now I'm hoping that even as you were working through these, you began to automate that a little bit. You might think at the beginning, it's a very common experience for me to hear people say in class, I'll never remember all these buttons, there's too much to remember here. The key to it is just repetition. The more of these you do, the more practice you do, the more that it just becomes something that you just remember, you just learn. Right, last one, 97. I'm going to go 97 equals shift fact. And that's interesting. What that tells me is just 97. So it doesn't seem for a minute to have worked there. I think, why would that be? Well, the reason it doesn't work for that 97 is not because there's anything wrong with the calculator. The reason it doesn't work for 97 is that 97 is in fact a prime number. It can't be broken down into into other numbers multiplied together because 97 is itself prime. Now that's quite an important point because it introduces a really, really useful thing you can do, which is you can use the calculator to work out if a number's prime, if you don't know if it's prime. Let's have a look at an example. So we've got 3 numbers here, and one of these is a prime number, but we don't know which one. So let's look how we could do that. Well, to work out if it's prime, I mean, you could start thinking, what can I divide 207 by? Or what can I divide 209 by? And see if you can find something. But they're quite big numbers. So a much better way of doing that is to actually express them as a product of its prime factors. So I'm going to do the same thing as done before. Grab my calculator. So 207 equals shift fact. And that tells me that 207 as the product of its prime factors is 3 squared times 23. That means 207 can't be a prime number because it can be written as as smaller numbers, as prime numbers multiplied together. You can do the same with 209. 209 equals shift fact. 209 expressed as the product of its prime factors is 11 times 19, so it can't be prime. 211, if we do the same thing, 211 equals shift fact is just 211. In other words, that is the prime number. You can't write 211 as anything other than 211. It can't be expressed as other prime numbers multiplied together. So yeah, it's just a useful thing. It's a little kind of almost a cheat, if you like. It's very handy to know some of your early primes. If you know that 2, 3, 5, 7, 11 are prime, really useful. But for later ones, you don't need to worry about remembering them. Just remember that trick. Express it using the calculator as the product of its prime factors. And if you get something like this, you know it's not a prime number. If you get something where it's just the number gets fed back to you, then it's a prime number. All right, we're going to go back now to have a look at something a little bit different. This is or something that we've looked at before. We're going to just take it on a little bit further. This is finding what we call the highest common factor of two numbers. Now, the highest common factor is almost always abbreviated to HCF, not so much in exams, but definitely in textbook exercises, on videos. You almost always see it given as HCF. As it says here, it's the largest number, which is a factor of both numbers. So let's take an example of that. It's much easier to see an example in practice. So I want to find the highest common factor of 12 and 20. In other words, what number is the biggest number? There's a factor of 12 and a factor of 20. Now, the key here is remembering what we mean by factor. Factors are the numbers that go into a number, the numbers you can divide something by. So to find the highest common factor, what I'm going to do is I'm going to first of all find the factors of 12. This is the horseshoe method we looked at before. So I'm going to go 1 times 12. I'm going to go 2 times 6. After 2 comes 3, so that's 3 times 4. After 3 will be 4, but that will be 4 times 3. That's just the same thing, but turned around, so you don't need to worry about that. So those, always a tricky part, those are the factors of 12. Now the factors of 20 are going to be, well, let's do the same. We're going to go 1 times 20, 2 times 10. After 2 comes 3, but 20 doesn't divide by 3. I mean, not to give you the whole number. And again, you can remember, you can always use a calculator if you're not completely sure about that. But 20 divided by 3 would be a messy decimal, so not that. After 3 comes 4. Yes, that will work. 4 times 5 makes 20. Then we'd have 5 times 4, but that's the same thing as 4 times 5 just turned around. So again, that means we've found all the factors. So let's make our little horseshoe here. And what can we see? Well, if we look here, we can see that we've got some common factors. We've got numbers that are in the factors of both. So 1 is a factor of both, 2 is a factor of both, but the highest common factor is 4. 4 is the biggest number that is in both, is a factor of both numbers. Right, so I'm going to give you one to have a little go at. So I'd like you to find the highest common factor. I'm just going to check what I gave you before. That would be 18 and 24. Sorry, this is on the PowerPoint as well. Right, excuse my appalling handwriting. That says find the highest common factor of 18 and 24. So I'd like you to do the same method over here. Find the factors of 18, find the factor of 24, and then look for the biggest number that's a factor of both. And I suggest you pause the video now, have a go at that. Okay, so for factors of 18, we'd have 1 times 18. After 1 comes 2, so 2 times 9. After 2 comes 3, that would be 3 times 6. After 3 comes 4, but 18 doesn't divide by 4 to leave you with a whole number. 5, 18 doesn't divide by 5 to leave you with a whole number. 6, we would have 6 times 3, but that's the same as 3 times 6, so that means we've found all the factors of 18. If we do the same for 24, try and squeeze it in here a little bit. Right, here we go. So for 24 will be 1 and 24, 2 times 12, 3 times 8 and 4 times 6. And again, we'd have a 5, but 5 doesn't multiply by anything to make 24, and then it would be 6 times 4. So we know we've found all the factors of 24. Just about getting out in there. And again, we can see we've got some common factors. 1 is a factor of both numbers, 2 is a factor of both numbers, 3 is a factor of both numbers, and 6 is a factor of both numbers. So the highest common factor, the biggest number, that's a factor of 18 and a factor of 24, is 6. And that's it. We'll give you lots more examples in class. There's, in the little textbook, the exercise book you've been given, there's more examples there. You'll find more questions on Hegarty Maths. One thing to say about this is, with highest common factor, is there are other ways of finding it, but they're a bit more complicated, and they tend to be something you would do if you didn't have a calculator. Because you've always got a calculator, it's just a lot easier, I think, to just list them all out like this. There might be the odd question where another method would be a little bit quicker, but this, I think, is just an easy, reliable method to learn. And you don't have to do lots of sums, because all the time, whenever you get stuck, you use your calculator. So that's why we're teaching this one rather than giving you on Hegarty, because I think it's just the method on Hegarty is more complicated than it needs to be, bearing in mind for you that you always have a calculator. Right, another thing. This is called finding the lowest common multiple, or the LCM of 2 or more numbers. And as it says here, the lowest common multiple of 2 numbers is the smallest number, which is a multiple of both. Let's look at an example. So I want to find the lowest common multiple of 12 and 20. So what does that mean? Well, it means we need to find a number that's the first number that's a multiple of 12 and a multiple of 20. And again, the key to this is remembering what we mean by multiple. So the multiples are the answer to something's times table. So multiples of 12 would be, oops, try that again, 12, 24, 36. Now, if you don't know your 12 times table, that's fine. All I'm doing here is just adding 12 to each number as we go along. So you can, if you don't let me the fact that I know my 12 times table, don't let that put you off. If you don't know what these are, just remember that all you're doing is grabbing your calculator and you're going 12 plus 12 is 24. 12, so 24 plus 12 is 36. 36 plus 12 is 48. 48 plus 12 is 60. 60 plus 12 is 72. Just keep adding 12 on each time. I've just gone so far down. I've not gone any further. I might need to go further, but let's have a look for the multiples of 20 first of all. So multiple of 20 would be 20. Plus 20 is 40. Plus 20 is 60. And there we can stop. We can see that 60 is a multiple of 12 and a multiple of 20. So 60 is the lowest common multiple. It is the smallest number that is a multiple of both those numbers. Right, so I'm going to ask you now to find the LCM, lowest common multiple of, again, I just need to check my notes for 1 second. I said here 18 and 24. Again, sorry, that's a poorly handwriting. We'll just rewrite that a little bit clearer. Lowest common multiple of 18 and 24. So again, you're writing the multiples of 18, write the multiples of 24, and look for the smallest number that's in both lists. Again, suggest that you pause the video, have a go at that, and then I'll go through it with you. Okay, so first of all, we need to find the multiples of 18. So that's, again, the answer to the 18 times table. Try again. Right, so that's 18 plus 18 is 36. Plus 18 is 54, again, using my calculator. Plus 18 is 72. Plus 18 is 90, and so on. I may need to go further, but I think we'll just stop there for a minute and let's have a look at some multiples of 24 and see if we get a number that's common. So multiples of 24 are 24 plus 24 is 48, plus 24 is 72. And in fact, there we can stop. We can see that 72 is a multiple of 18. It's a multiple of 24, so 72 is the lowest common multiple of 18 and 24. Now again, there are lots of examples on Hegarty Maths, although again I suggest that you don't worry about the video there because the method he uses is going to be something that assumes you may not have a calculator. So it's a little bit more long-winded than you need because you always have a calculator. But the exercise is generally pretty good. Corporate Maths again will be another good place if you want to look for some lots of questions on that. The textbook, the little exercise book that we've given you would also have lots of examples in there. So there's plenty of place to find practice questions on those. Now, here's the main thing, the thing I really want to stress. The number one problem people have with highest common factor and lowest common multiple is they get mixed up between the two. For as long as I've been teaching, I've known students confuse these. It is extremely common to find that a question says, find the highest common factor of two numbers. And the student does it confidently and correctly, except that they've worked out the lowest common multiple of those numbers. It's such an easy thing to happen, and there isn't really an easy way around it, except, I think, for me to stress, focus on the words factors and multiples. That's the important thing. If you remember what factors are and you remember what multiples are, and you keep that word clear in your mind as you're doing these questions, I think that you minimize the chance of making a mistake. I think a common problem is that highest common factors tend to be relatively small. If we just look back for a second here at an example. So the highest common factor of 12 and 20 was just 4. The highest common factor of 18 and 24 was 6. So I think because it's got the word highest in there, people tend to kind of, part of their brain tends to kind of think this should be a big number. Highest common factors are little numbers, or usually smaller than the numbers you're given. In contrast, where are we? Lowest common multiple answers, are bigger or big. They are normally bigger than the pair of numbers that you're given. They're at least as the lowest common multiple can't be any bigger than it can't be smaller than the bigger of the two numbers. Don't worry for that. Probably just fluff my words there a bit, but you get the idea. Lowest common multiple numbers are big numbers, whereas highest common factors are small numbers. So if you are absolutely and completely aware of the fact that that there's a risk of making a mistake, you minimize the chance of making a mistake with these. I just want to stress this because I see this over and over again. Some of you watching this video will still do this, possibly even do this on exam day. So be aware that people get these two mixed up. If you've got any doubt or confusion about what I'm saying here, talk to us in class and I will try and emphasize the point. But it's just such a common mistake people make. Right, and I've got a few questions here, and I'm not going to go through these with you. I'm just going to point out these are on the PowerPoint. So if you wanted some practice, this would be a first good point to go to. There's a mixture of questions: highest common factor, lowest common multiple. Some of these you'll find will be relatively quick and easy. Some of them, I think the last one here, this might take a little bit of working out, particularly for the lowest common multiple. It's not a small number, that. But we just thought it was worth giving you some examples there. But as I said, there's also lots of examples on Hegarty, on Corbett Maths. There's lots of other places that you can go for examples here. It's a very common exam question and one I definitely want you to be aware of. And that's it. That is everything for today's lesson. As I said, we've covered a lot. Some of it I think is relatively straightforward. Some of it's going to take a little bit longer. Again, a very common experience when I'm running this kind of lesson in class, if people say there's too much here, there's too much I'm trying to remember, I'm not going to remember all this. All I can say there is it's regular practice that's the important thing. The more times you've seen this, the more times you've practiced it and experienced it, the better. It's a bit like learning to drive. When you first get in a car for the very first time, everything feels clunky. You're having to learn absolutely everything. You think you'll never be able to remember everything, all the buttons, what goes where, when to press the clutch, all that kind of stuff. After a while, and for those of you who've been driving for a few years, you do it automatically. You can do it quite happily listening to music. You can happily talking to somebody, whatever, and you don't even think about it. It becomes automated. And the reason for that is not because you spent a long time, if you like, reading driving books. It's because you practiced it. It's because you didn't. It's not because you watched other people driving. It's because you did it. You practiced it, and you just got used to the process of driving, and things became automated. And it's the same with maths. The more that you actually do, the less you can stop listening to someone waffle on about it, and the more that you actually do it yourself, the more practice you have, the better. So that's why I want you to spend as much time as possible with a pen and paper actually doing maths and writing things down, attempting questions. You don't need with maths to spend a lot of time revising. You need to spend a lot of time practicing. Just do more and more maths and more questions. The more you do, the better you'll be. Right, that will do us for today. So I will wish you a good rest of the day, and I will see you back in class before long. Or if you're in Dave's class on Wednesday, then I will see you in class at some point. That's all. Bye for now. Bye.